Hello everyone and welcome back. In this tutorial I'll show you how easy it is to use V-Ray instances and the V-Ray UserColor text map directly from within the NodeWorks. The only requirements are FumeFX 755 or newer and V-Ray 73002 or newer. You can find the finished scene inside the FumeFX example files along with more than 160 other examples. So let's get started. Here I have a plane with a V-Ray material applied using a bitmap in the diffuse channel. The plane dimensions match the image so we avoid any distortion. Inside NodeWorks, I want to generate a teapot shape at the center of each polygon. To assign shape to particle, I'll use the shape instance node. This node is supported by Arnold, V-Ray and F-Storm, and it tells those renderers to render a single shared mesh at every particle position. This not only saves memory, but also significantly speeds up rendering. I'll scale the teapot down a little and add a 45-degree rotation. If you want to reduce variation, introduce some variation, you can do that here as well. But in this case, I leave the variation at 0. For the viewport, we don't actually need to display the geometry, so instead I'll switch the particle to large dot and set the color to particle color, which we're about to set up. Each instance shares the same memory, but every particle can carry its own properties, transformation, color, or custom channels. To write per particle color, we need to evaluate the text map directly underneath each teapot and assign that color to the particle. The Texmap node is exactly the right tool for this. As you can see, it requires a position and UVW input, both of which the surface node provides out of the box. When we connect the position, NodeWorks automatically wires UV as well, so all that's left is to choose which text map to evaluate. Inside the material editor, select the slot that contains the bitmap text map. On the text map node, right-click on the text map 1 button and choose Get from Material Editor Active Slot. As a final step, I'll add a color node to write the color information back to the particle itself. Now I'll create a single V-Ray material, and for the diffuse I'll choose V-Ray UserColor. Here, for the attribute name, I'll type fxp_color, which tells V-Ray to use the NodeWorks particle attribute as the diffuse color. Finally, I'll assign this material to the NodeWorks object and open the V-Ray frame buffer to see the final result. Here you can see that NodeWorks uses particle attribute, which is default, but you can use the custom channel as well. So if we create one Flow 3 custom channel and assign the color to that channel instead to the particle color channel, we just need to go to the V-Ray text map and rename the channel to fxp_mycolor, and we get the same result. Now, changing color directly inside NodeWorks means that the system has to recalculate the entire simulation every time you tweak something. If you want, for example, to drive color based on particle velocity or any other scalar value, there's a much better approach. We change the color purely inside the shader, so the simulation stays untouched. Here's an example of cubes colored by the OSL Color Curve shader driven through the V-Ray UserScalar map. Let me show you how to set this up. I'll start with the Surface Gen node configured to give the particle a wide range of velocities, and I'll write those velocities into a float custom channel, and we want to remap those velocity values into 0 to 1 range. But first we need to know the actual particle speed. Using the display node, you'll notice the speed is shown as two values. NodeWorks displays units per second inside the user interface, but internally it stores the value as unit per frame. We want to use that second value, the per frame speed of the fastest moving particle, as the maximum of the remap node. Inside the material editor, choose OSL Color Curve, and for its input, plug in a V-Ray UserScalar map pointing at our custom channel. Remember to prefix the channel with the FXP underscore so V-Ray knows where to read it from. And as you can see, that's it. Very simple, very flexible. With just a handful of nodes, we've driven thousands of instances directly from NodeWorks, each one picking up its color from the bitmap underneath and now reacting to particle velocity through the shader itself. No res simulating, no baking, just fast art directable color from inside the renderer. Thank you for watching, and I'll see you with the next tutorial.